Hello everyone, in this video, I would like to show this test how can we build up the EtherNet IP communication between Schneider PLC and Siemens PLC. If we go back to 10 years ago or even 5 years ago, basically when we build up the communication between the Siemens controller and the Schneider controller, the main method we would use Modbus TCP. By recent years, Schneider Modicon released this M241, M251, and M262, this new platform controller, and their new software named EtherNet Expert this platform. And this controller has EtherNet IP scanner and EtherNet IP adapter function. Also, Siemens controller S7-1200, 1500 PLC, other than their built-in PerfectNet, Siemens also released the solution enable the Siemens controller to run EtherNet IP scanner and adapter. And since this controller can run as EtherNet IP scanner, and this is the hardware based, and Siemens, their mainstay, this is the software based. So that's why if you have to use EtherNet IP solution, I would recommend you run the Schneider Modicon controller running as a scanner, and the Siemens side can run as EtherNet IP adapter. Both sides can implement this Ethernet IP communication very easily. I will show this case. And in one previous video, I showed very detailedly how to implement this Ethernet IP adapter device feature from Siemens side. I highly recommend you could review the details, implementation, and program from the one previous video. If you go to my channel, Electrical Automation Hands-On, and you search COM28 Ethernet IP adapter, Siemens S7-1200 1500 PLC, communicate with Allen Bradley PLC. Allen Bradley PLC will run as a scanner, and the Siemens side will run as an Ethernet IP adapter, the device. And I showed very detailedly how to download the example program and how can we program the detailed parameters inside. Basically, the implementation would be very easily. Couple minutes, you will understand how to program this. And if you do need to recall, we can go to Ethernet IP adapter. This is Siemens support website, and you can go to the application example and search this ID 1097823815, and you will find this Ethernet IP adapter. It provides 3 versions: TI Portal version 15.1, 16, and 17. It provides 3 examples and the libraries. Both ways, they all works. In this case, I'm using version 17, and I have one real controller, S7-1200 PLC. And more importantly, we have EDS file here. So you can download this EDS file. And from the Schneider Modicon EtherNet Expert platform, you can import this EDS file. And in this test, I will show how can we import the EDS file and how can we set up the communication. More importantly, from the Schneider side, I will show the byte transfer to word, how that works. Okay, let's turn to the TI Portal side and let me show how can we implement this briefly. All right, let's firstly go to the TI Portal side, the Siemens controller. In this test, I'm using Siemens S7-1200 1214, this CPU. So if I go to the device configuration, double click the hardware, the device configuration. So we will see this is my controller now. And the current firmware of this controller, it is version 4.4. Keep in mind, your controller's firmware need to be above version 4.2. Okay? And the current IP address of this CPU, if I click this port, we will see this 1200 PLC, its IP address is 192.168.1.181. We do not need to do any special hardware configuration at here. So the only things we need to do, we need to import the library. Okay, from the right side. And we need to open the global library. And we need to open the Ethernet adapter. So this Ethernet adapter library, currently it has 3 versions, 15, 16, 17. It depends on what the current version of your TI Portal version, okay? And after double click and open this library. Okay, After you open the library, we will see it has 1500 or 1200 library. Okay, the function block is quite the same. The key things is it has the function block, LCCF, Ethernet adapter, and it also have the date type. And then you drag this date type to the PLC date type, okay? And also this function block, you drag this function block to the program blocks, this area, okay? I already dragged this. Again, the detail of this implementation, the programming, you better review the video I mentioned before. So now this date type, it has this adapter, a diagnose this date type. You just copy paste here, that's enough. And the function block here. In this program, I'm using the cyclic interrupt 10 milliseconds. The cyclic interrupt and call this FB1, this Ethernet adapter, this function block, okay? And enable I set to true. And interface, this is the 64. The 64 again come from the hardware. If we double click the CPU hardware and go to the system constant, and here we will see the 64 that represent this hardware ID of this Ethernet port. That means we will tell this function block this hardware port will be used as this Ethernet IP adapter function. And this is high byte, low byte. And this is very important. By default, this function block may be shrinked like this way. You can expand. And this is 101 for the input, 102 for the output assembling, and 104 for the configuration. Those parameters match with the EDS file from the Siemens. And regarding the EDS file, again, you need to go to this application, this ID number, and don't forget to download this EDS file. The library we just talked, you download from here, or you can download the example. You can directly use the program from the example. And the data buffer, and let's go to the DB here, DB10. DB10 here, I declared 128 bytes for the input and the output. So this output from master, that's the data flow from the master, usually the Ethernet IP protocol code originator. Okay, this originator to the target. This is the control data received from the master. Okay, the data flow from the master to this adapter. Okay, and the input here, the input means this is data flow from the adapter to the master. This is from the device or from the target to the originator. Okay, and then we flow here, and then we will drag this output to the output here, and drag this input to the input here. The input and output represent the master. So input means the data flow from this adapter to the master. Output means from the master to this adapter. Okay, and configuration here. We prepare the same size as this input and output. Okay, and that's enough so far. And again, the IP address of that is the 129.168.1.181. Okay, that's enough. Now let me download. Click and download. Okay, the first time when we download this function block, the CPU need to be stopped. Okay, we are downloading this CPU. Okay, after we download, let's go to this cyclic interrupt and let's go online. And as we can see, so far we haven't configured the master, the Ethernet IP scanner side. So that's why this valid now it shows off. The function block is busy because it keeps searching the master. Okay, and this update interval haven't got update any value yet. That means it haven't connected the master, the scanner yet. Okay, now let's shift to the Modicon, the Schneider controller M251, this controller. And let's configure the M251 as the Ethernet scanner. Okay, and in the meantime, we will use the EDS file we download. Alright, this is Schneider system. And currently I'm using the Machine Expert version 2. This trial license allows me to use this software in 42 days. Okay, around 40 days. Okay, we just opened this project, and the controller what I'm using, this is the TM251. Okay, and this controller has a 3 Ethernet port. The first 2 Ethernet port, usually we call the Ethernet 1. And this port I configured as 192.168.0.221. And currently I'm using this port as the programming port. Okay, and if we click this configuration, and we will see this port only allows this controller run as the adapter, okay, or Modbus. But in this case, I'm going to use this M251 running as Ethernet IP scanner. So we will use the second one that only has one physical port. And if we click this port, so we will see this port allows us to configure this industry Ethernet manager and the Modbus IP slave device. Okay, we can add on this. So let's add this, add device. So let's firstly add this manager here. And then if we click here, we will see some difference comparing with Ethernet port 1. So this port 2, if we go here, we will see its target, that's the Ethernet IP targets. That means this port can run as Ethernet IP scanner, the master. At here, we should find the Ethernet IP adapters. Okay, so let's go to, to connect the Siemens S7-1200 PLC as the Ethernet IP adapter, firstly, we need to install the EDS file. So it's much easier for us to configure the device, right? So we can go to the tools, this device repository, and let's install the EDS file, install, and let's search the Siemens EDS file at the desktop here. Okay. Keep in mind this ID number from Siemens support website. This is the ID number. And from here, because we are using S7-1200 PLC, I will install this EDS file. Open. Okay, we install this. And click this Renew Device Repository. New versions of the import plugin are available. Okay, so after we click this device will be updated in their catalog. And this time, if we click this second port, this Ethernet manager, firstly, keep in mind, we need to select this protocol, switch to the Ethernet IP. Okay, here. Tell this port we are going to use Ethernet IP, this protocol. Okay, and currently we haven't configured the device yet, so that's why this list shows empty. And from here, let's click Add. And this time we can pick this catalog, go to the Siemens AG, so it automatically shows the Siemens only. Okay, let's click Add. Or if we select All, we can go to the field bus, Ethernet IP, adapter, and we can see this is a 1200 controller. Okay, and we can click Add. So the system automatically assigns one IP address. So we can go to this device and we can see this IP address. So as I introduced, this controller, the IP address is 1.181. Okay, here is very important, this electronic key-in. So this is check the device type, vendor code, and the product code, where this comes from. By default, they are on. So you can check it off. Or in case you need to enable this, so how to find this correct number? If you accidentally leave this on and if you download, your communication won't be connected, won't be successfully. So those number, you can find out those number from the EDS file. This is the 1200 EDS file. If I open it, so we will see the device type, the product type, and the vendor code, and the product code, and the product code. Okay. Or the easy way is you take it off. Doesn't allow the system check this key-in. Sometimes this key-in maybe cause the issue. So I would recommend to take it off. Okay. Okay, we have this IP address and go to the connection. And because we load the EDS file, so this system prepared this connection already. The only things we need to change is bytes. So if you recall from the configuration, I prepared 128 bytes. So I need to change to 128 bytes for the input and output. And this RPI cyclic time, I would recommend set above 20 milliseconds. Okay. If some cases you have some device, it doesn't have EDS file, then you have to add this connection by yourself. So basically you can select this user defined path. So you can type in the input output, or you need to, some cases you might need to enable this configuration. Okay. In this case, Siemens doesn't care about the configuration. After all, that side is a controller, right? It doesn't allow you to configure something. That's why this config size, this config 1 or 2, that value doesn't matter. Okay, you do not need to care about this. Okay, but some device maybe it need the configuration assembly number. So this ID, the input and the output ID, you need to carefully about this. Okay. So in this case, we are setting 128. And because we set 128, now if we shift to the Ethernet IP I/O mapping here, the system will prepare the 0 to 63. So this is 64 words. That means 128 bytes. Okay. And this mapping here, that can map with the internal variables from this PLC setting. Go to the application tree. If we declare the variables, so we can map the variables. Okay. But in this case, we'll mainly focus on the communication only. So I won't map any variables at here. Okay. And we haven't downloaded yet, so this status shows nothing. Okay. And keep in mind, I would recommend to take off those keys. Okay. Now let's download. Okay, let's compile. And no error. In the meantime, from this manager, we will see after we add this device from this network manager, this list, we will see this is the IP address and this is the device. Okay. And let's download. Now log in. Okay, Auto F. And the Modicon, this controller has login, password, and username. Okay, log in the program. Perform download. Okay, let's start up the controller. Start. Alright, we can see all the icons shows this green circle here. That means all the status, they are good. So if we double click this controller here, 1200, and we can go to the status, and it's showing running. That means it found this controller. That means this master, this scanner, it found this Ethernet IP device. Okay. And if we go to this manager here, we can see this status. Okay, it's showing this scanner is running. And in the meantime, we can click this Ethernet resources. It can calculate the current resources. And for this M251, the maximum value, that's the 16 devices. Okay, keep in mind this number. And totally, it can read or write the words. So it's 1K words. Okay. Now let's verify the I/O data. Go to the 1200 controller. Go to this Ethernet IP I/O mapping, and we will see this is the input and the output. Let's prepare the value, saying this is 100. Okay. The second word, this is the 200. The third, that's the 300. And the last word, let's go to the last one, and let's write 128. To write the value, transfer from the prepared value to the current value, we can go to the debug, click this right value. Okay, now we prepared this value 128 and 100, 200, 300. And now let's shift to the Siemens PLC side. Okay, the right side, this is the Siemens side. So again, so the right side, this is the Siemens side. Now, if we go online, click this online, and we will see this time, because this communication now is correct, so this valid shows true. And this update time is showing the update interval time. Okay, and let's go to the DB. And we will see here, receiving the data, the output from the master. The first data, that's the 100. This is from the word. And second word, that's the 200. But here it's showing something like this. That's because here from the Siemens side, that's the bytes as a unit. But from the Schneider side, that's the word. It prepared as a word. Okay, if now we go to the bottom here, the last one, 128, we will see the 128 is receiving correctly. However, it's receiving this minus 128. That's because this is a signed integer. So firstly, it's transferring the data. However, because of the word and the bytes, so that's why the data is showing a little bit weird. So let's firstly verify this way. So if I type in 16 palm AA this way, so that's the 170. Now let's transfer this data first. Right. So when I transfer the 16 palm AA, so the decimal number, that's the 170. But the Siemens side is receiving minus 86. So I can use the monitor watch list here. Let's create one watch list, add a new watch table here. And I can drag this 2 bytes, 126 and 127. Because 126 and 127, that represent this word. Okay? And if I change this format to the hex, okay, we will see something. So that means when we send AA, this is the low bytes, and this is the high bytes. Okay, so this time if I prepare, let's say AACC, and then let's write the value AACC. Okay, we will see the AACC is here. So that means this is the low bytes and this is the high byte, right? So now let me use the first data for a try. So if I go up, this is from the DB, right? And let me drag this 0 and 1 here. Okay, change to hex. Change to hex. Okay. So this time for this output, if I type in 16 palm, so AAEE, okay, AAEE, if we send out, right. Okay, we will see AAEE. EE come from the low bytes and the AA come from the high bytes. Okay, so keep in mind this low and the high bytes. Keep in mind here. And this time, let me test the send data. Okay, and let me go to the DB. And let's test the input to the master. Okay. And from here, let me prepare this low bytes, prepare 111. Let's prepare 112. Okay. Okay. It's easier to watch. So now let's go to the input from the Modicon side. So we will see, because this is the first 2 bytes, the first 2 bytes combined together, that's this first word. So that's why the value shows not the same. But if I delete this to 0, then it will show 111. If I prepare the 112 for the third one, the third byte, That's actually, this is the second word at here. So they are matching. Okay. So if now I send here the lower bytes, say hex number, this is the EE. Okay. And this one here, I will prepare AA. Okay, I prepared AAEE. And let's calculate here. So this time, so the Schneider side is showing 43758, right? So we will see 43758, this value, that is the hex number AAE, exactly the same like here. This is the EE, and this is the AA. AA come from the high bytes, and the lower bytes come from the EE here. Okay, so if I drag this two value to the watch list this time, the watch list allows us to shift the data wheel, and I can shift this to hex number. So as we can see, this EE, AA come from the high bytes here, and this is low bytes here. So entirely, this is the first word, that's the 43758. Okay, and then you just need to do some like a logic transfer from the byte to the word. They can match together. Okay, but this communication, they are correct now. Especially sometimes you only need to transfer some bytes over the bool, so it doesn't matter this word or byte anymore. You just transfer, right, byte to byte, bit to bit, so they can communicate each other. And from the status here is showing this status of the master and this slave. Click this 1200 device, and this adapter, the status showing running. In the meantime, if we go to the web page of this controller, if you recall, I'm connecting this port. Its IP address is 0.221, and I configured the web page. Okay, so I can browse the web page of this controller 192.168.0.221. Okay, let's enter, and it asks me the login password. Okay, login. Controllers shows the controller status. Okay, and especially let's go to the Ethernet 2. Ethernet 2 showing this is the Ethernet IP of the Ethernet 2 port. Okay, this is the IP address of these two ports. And from here, you can test, you can pin the target. My target, that is the 1.181, right? I can click the pin. Okay, it shows this controller can find this Ethernet IP device. Okay, this is the Siemens 1200 PLC. And if I go to the scanner status, here is showing the operational. That means this scanner, this master is working. That is, this is manager. This manager is working now. Okay, and then let's go to the Ethernet IP status. So this is showing the totally 16 devices, what the status of them. So this 257 is showing correct. Okay, if now I go to this configuration here, if you recall, this 257 that actually come from the connection. This is here. So this 257 for this device is running properly now. It's showing green. So now if I unplug the Ethernet port, so for example, I unplug the Siemens port. And we will see the web page will show this device connection. It dropped the connection. The status is not correct. And from the software, we will see this triangle here. And from the status here, we will see this model report an error. Okay, if now I recover this connection, and we will see from the software and this device showing the running, and the web page will show this disconnected. And this web page shows this device status. Okay, I like this feature. it can show this Ethernet IP device what the status from this controller. Okay. Now let's do a test. Let's shut down the power both on the scanner side and this device side. I will shut down the power for this 1200 PLC and Schneider this PLC. I will shut down the power for the Siemens side and this Schneider side. Okay, let's cycle power. Okay, I kill the power. And both sides will lose the connection. Okay, now let's power up. Okay, Siemens side it power up, and the Schneider side in a couple of seconds. Okay, they all powered up and lit up. And now let's try to reconnect and see the current status. And let me log in this controller. And in the meantime, let me go online for the Siemens side, TI portal. Okay, we will see the value shows true again. That means the connection connected already. And if we see this side, this status, that means the master and this device, they are communicating. Okay, this is the master status, and this is the device status. In the meantime, let's go to the web page. So it's showing the status on again. So that means even we shut down the power on the both side, or we disconnect the Ethernet port, it doesn't matter. Both the scanner side and the device side, they can recover the communication again. This is really great. All right, this is all my test for this connection between the Siemens 1200 and the Schneider Modicon M251 via the Ethernet IP communication. And in this test, the Schneider Modicon side running as the Ethernet IP master scanner, and the Siemens side running as Ethernet IP adapter. Thank you for watching. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.